I wanted to put it on integrity, so I had proof that I said this. On your take-home test, go ahead and write on your test these very important things. Number one, that take-home test is due 1 week from today. I think that is the 17th. Is that right? So your test is due on the 17th, and I will take it up at the start of class. So it will be due at the beginning of class. I will not take these papers late, period. Okay? So make sure they're done, ready to turn in at the beginning of class on the 17th. Now that you have the due date, other requirements, you must show every single bit of your work. And I would write that on the take-home test somewhere. You must show all of your work. And then, of course, your answers need to go in the answer blank. Bonus points to be turned in with this, if you choose, will be 9.3 through all of Chapter 10. So those are the bonus points opportunities that if you want to turn them in with this test, it's 9.3 through all of Chapter 10. So if you missed any of that, it's on integrity. Go back and listen to it. Okay. So no questions about anything at all. All right. So we're going to start into Chapter 10. Hopefully you printed off your formulas for Chapter 10, and if you wanted the PowerPoints, they were there also. Speaking of, back in Chapter 9.5, the homework for 9.5, I only want you to do 1 and 3. Don't worry about doing number 7. The homework in 9.5, just do 1 and 3. Don't worry about doing number 7. Okay, so Chapter 10. What we're going to do in Chapter 10 is we're going to review a little bit about limits. So now you haven't done limits in a long time. We have not done limits since, well, I guess it was Chapter 2 of Cal 1. So it's been a while. So let's review a little bit about limits. This is just a basic problem from Cal 1. And remember, every time you do a limit, and this is extremely important, okay, because I'm going to teach you new limit techniques tonight. I don't want you to get caught up in the new techniques and forget about the old techniques, all right? So you have to remember your Cal 1 techniques. First things first, let's look at this one. First thing we always want to do is we will always want to try to plug in the limit. So for here, example, the limit as x approaches 3. Well, let's try to plug in 3 and see what happens. So if I plug 3 in, I'm going to get 3 squared, which is going to be 9 minus 9. And then I'm going to get 3 minus 3, and we're going to get 0 over 0, which you know is undefined. Tonight, you're going to learn that we call this an indeterminate limit. Indeterminate. Which means, basically, that you just cannot determine where that limit is going to be. You can't determine where it's going to reach. Now, you do remember what limits are, yes? You plug in an x, the limit is the y. Okay? So you plug in an x, and the limit is how high or how low you can go. That's what your limits are. Also, you remember that sometimes our graphs, because we are talking about graphs, sometimes our graphs go to positive infinity, and sometimes they go to negative infinity. Some people say that those do not exist because infinity is not technically a limit. we'll talk a little bit about that tonight as far as how I want your answers to look. So this, the way we've got it set up, is undefined or indeterminate. Well, tonight I'm going to teach you some other steps to do, but first let's rely on Cal 1. Always rely on Cal 1. So your first option is to plug it straight in to see if it exists. It does not exist if we plug it straight in. Step number 2 that we learned in Cal 1, try some algebra and see if that works. So if we try some algebra in the numerator, that's the difference of two squares, and we can factor that. So that's going to go to x plus 3 times x minus 3. Well, what happens to the x minus 3 groups? They cancel out. So now what you have is the limit as x approaches 3 of x plus 3. Well, let's apply the limit here. If we apply the limit here and just plug that 3 straight in, look at what happens. And we determine that the limit as x approaches 3, your limit approaches 6. Okay? So that's how high this thing would go if we actually had to graph it. Now we did talk about left-handed limits and right-handed limits, how you approach from the left and how you approach from the right, and so on and so forth. We'll talk a little bit about that tonight. It really and truly won't come into play, but I do want you to have a visualization of it. The most important thing, and probably one of the hardest things about limits, is the fact that you have to be able to visualize the graph. You have to have a common, generic concept of what the graph is doing. And if you can do that, then you'll be okay. You'll be okay on the graphs. All right. So, this is a review of Cal 1. So let's look at example number 2. Example number 2. Always, guys, listen to me, okay? Don't get caught up in L'Hopital's rule. Don't get caught up in the new techniques. Go back to your Cal 1 stuff first. Okay, so the first thing I want to do in example 2 is I want to try to plug in 1. So if I plug in 1, what's going to happen? On the top, I'm going to get what? 2 minus 5 plus 6 minus 3. What's that going to be? It's going to be 0. On the bottom, I'm going to get 1 minus 2 plus 2 minus 1. What's that going to be? That's going to be 0 also. So what is this called? This is an indeterminate limit. Because I get 0 over 0. Well, from Cal 1, if plugging it in doesn't work, what's the next step? Algebra. Try some algebra. Do you see 4 terms? We talked about this last time. If you see a 4-term polynomial, what's the only way you know how to factor it? By grouping. Factor by grouping. Well, if we group this, let's try the numerator. If we group this numerator, and let's say that we factor out x squared out of the first one, that's going to leave us with what? 2x minus 5. And out of the second one, we can factor out a 3, which is going to leave us with an x minus 1. Is it going to factor by grouping? No. Why? These two groups are not the same. So we can't do any algebra. Well, darn. If we can't do any algebra, then in Cal 1, we try the left-handed limits, the right-handed limits. Just to let you know, every technique you try from Cal 1 will not work. So when you come up with an indeterminate limit, try some algebra, and if the algebra doesn't work, then we'll go into L'Hopital's rule. Now, L'Hopital's rule states this. Let me kind of sort of decipher this for you. If you have a fraction, a quotient in your limit, if you have a quotient in your limit as x approaches some number, and you come up with an indeterminate form, 0 over 0, and also we could get infinity over infinity, which is the same thing. So, when you get an indeterminate form, whether it be 0 over 0 or infinity over infinity, what we're going to do you remember what this notation means? derivative. What we're going to do is we're going to apply the limit to the derivative of the top and the derivative of the bottom. So let's see if that works. So let's apply L'Hopital's rule. And now we're going to have the limit as x approaches 1 of 6x squared minus 10x plus 6 over 3x squared minus 4x plus 2. Now let's apply the limit again. Okay? So L'Hopital's rule states if you get an indeterminate limit, meaning you get 0 over 0 or infinity over infinity, take the derivative of the top, the derivative of the bottom, and apply the limit again. So let's try it again. If I plug 1 in now on the top, I'm going to get 6 minus 10 plus 6, which is going to be what? 2. And if I apply the limit on the bottom, which means I'm going to plug 1 in the denominator, I'm going to get 3 minus 4 plus 2, which is what? 1. So the limit is 2. And we got an answer. Okay? So, one more time. If you come across these limits, first try your Cal 1 techniques. Okay? And if they work, some of them will. Even in the homework that I gave you, some of your Cal 1 techniques will work. Okay? So, try the Cal 1 techniques first. If the Cal 1 techniques end up giving you an indeterminate form, 0 over 0 or infinity over infinity, first thing you're going to do is apply L'Hopital's rule. If you have a quotient, okay? If you have a quotient, a fraction, a function over a function, L'Hopital's rule says to take the derivative of the top, the derivative of the bottom, and then apply the limit again. Sometimes, and we'll work one of these, sometimes, and I think in your homework you have one where you'll have to apply L'Hopital's rule 4 times before you actually come up with it. Okay, so it can get kind of messy. But what happens is if you apply L'Hopital's rule and you do the first derivative and you still get an indeterminate form, you have to do it again, find the second derivative. Find the second derivative, apply the limit, see if you come up with an answer. If you don't come up with an answer, apply L'Hopital's rule again and do the third derivative. And just keep going until eventually you'll come up with an answer. Okay? Any questions on L'Hopital's rule?
Yeah, this only works if it's a
quotient. Yes. It only works if it's a quotient and you have an indeterminate form, 0 over 0 or infinity over infinity. That's the only time it works. Okay? So let's look at this one. We have a quotient. So let's first try to apply the limit itself. Now obviously this is trig and there's nothing we can do to this. So the algebra thing from Cal 1 is out the window. But if we apply 0, you got your calculators, you're going to be using your calculators a bunch tonight. So go ahead and get those out. In your calculator, see if you can figure out what the cosine of 0 is. What is the cosine of 0? 1. And then, of course, if you plug 0 in for x for the 2x, that goes to 0 minus 1. So on the top, we get what? 0. On the bottom, of course, 3 times 0 is just 0, so you get 0 over 0. That's an indeterminate form, right? 0 over 0 or infinity over infinity. That's indeterminate. Well, can't do algebra because we have some trig in this. So let's apply L'Hopital's rule. Applying L'Hopital's rule says that we're going to take the derivative of the top and the derivative of the bottom. What's the derivative of cosine x? You need your derivative page if you don't know it off the top of your head. What's the derivative of cosine x? Negative sine x. What's the derivative of 2x? 2. And the derivative of negative 1 is 0. The derivative of any constant is 0. Okay, so the derivative of the bottom, the derivative of 3x is going to be what? 3. Now, let's apply the limit again. So this time, what is, in your calculator if you need to, what is the sine of 0? sine of 0 is 0. Okay? So you get 0 plus 2 over 3, which is 2/3. And there's your answer. So make sure you know how to find derivatives. If you need your derivative page, go ahead and get that out. I don't think you'll need your trig identity sheet. I mean, if you want to get it out, you can, but I don't think you'll need it. Okay, let's try this one. Let's try to apply the limit right off the bat. Now, in algebra, we learned that anything to the 0 power is what? 1. Anything to the 0 power is 1. Tonight, we're going to learn something a little bit different than that. But as far as you know right now, anything to the 0 power is 1. So e to the 0 power is 1. E to the negative 0 power, of course, 0 is neutral, so it doesn't matter. That's still going to be 1 minus 2. So on the top, we're going to get 0. On the bottom, we're going to get 1 minus. What's cosine 2x if x goes to 0? Cosine of 0. What is cosine of 0? So you're going to get 0 again. So there's your indeterminate form. And since this is exponential and trig, can't do any algebra to it. Nothing you can do really to fix that. So you have to apply L'Hopital's rule. So let's take the derivative of the top. So the derivative of e to the x is what? E to the x times the derivative of x, which is 1, so we kind of omit it, but don't forget it's there. Okay, what is the derivative of e to the negative x? If f of x is e to the negative x, what's the derivative? The derivative of e to the u is e to the u times du. The derivative of negative x is what? Negative 1, so this is going to turn into minus e to the negative x. And then, of course, the derivative of negative 2 is what? 0? Okay, so go to the bottom. The derivative of 1, the derivative of any constant is 0, so that's just going to be 0. So we have 0 minus the derivative of cosine 2x. Well, if f of x is cosine, technically it's negative cosine 2x, what's the derivative of cosine? So the derivative of cosine u is negative sine u du. What's u? And what's the derivative of 2x? 2. So what does that turn out to be? 2 sine 2x? Again, it's very important that you know how to take these derivatives. Every bit of that's Cal 1 stuff. Okay, let's apply the limit again. E to the 0 we know is 1. Minus e to the 0 again is still 1. Over 0 minus. What did we say sine of 0? What is sine of 0? 0. So we're going to get 0 over 0. Well, it's not. You got an indeterminate form again. So now what are you going to do? You're going to take the derivative again. You're going to apply L'Hopital's rule one more time. So we're going to have the limit as x approaches 0. So let's apply the limit to the top and the bottom one more time. Derivative of e to the x is still e to the x. What happens to minus e to the negative x? It goes back to plus e to the negative x because of the derivative that we took earlier. Now on the bottom, if f of x is equal to negative 2 sine 2x, what is f prime of x? What's the derivative of sine 2x? Cosine 2x times 2. So you're going to get negative 4 cosine 2x. Do what? Okay, so let's go here. Let's apply the limit. We took the derivatives, now let's apply the limit. E to the 0 is 1, plus e to the 0 is 1, which is going to be 2. And then cosine of 0, what did we say cosine of 0 was? Cosine of 0 is 1 times negative 4 is going to be negative 4. So we come up with negative 1/2.
Here came out with say 1/0.
1/0, and that's where knowing what the graphs look like comes into play. 1/0, for mathematical purposes, we say that's undefined. But when we're talking about limits, we're talking about graphs. How high or how low does the graph go? So if you get anything over 0, in our case for these graphs, that means that there's an asymptote there, which means it causes our graph to either go to positive infinity or negative infinity. So anytime you get a number over 0, for the limits, your answer is going to be infinity. And for these indeterminate limits, the directional infinities don't matter. It doesn't matter if you put negative infinity, positive infinity, it's still all infinity.
So if you just get a constant, a 1 or something in there, that'll be your answer.
If you get 1, your answer is just going to be 1. If you get 1/0, your answer is infinity. If you get 0/1, your answer is 0. Yes, ma'am.
If you did the Calvin technique, you just look for the first one and just plug it in, and you got an indeterminate limit, and then went straight to rule, would you get the same answer like if that problem had a factor and you just ignored the it factor?
For example, if we did,
Like the first one we did, if we did that, if we used the rule,
I don't know.
would we get the same answer?
Let's try it. So we got an indeterminate, so if we take the derivative, we're going to have the limit as x approaches 3. The derivative of the top is going to be 2x. The derivative of the bottom is going to be 1. So 2 times 3. So yes, ma'am?
So you could just plug it in, and if that doesn't work, just go straight.
You're good. But what happens if your derivative is really, really nasty? I mean, it's to me, I'd rather do some algebra, especially if the derivative is like the quotient rule or the product rule or something like that. But if it's simple enough, then yeah, definitely. Okay, let's talk about infinity. These, I think, yes, these are on your cheat sheet, so you have them in front of you. But you're going to use them so much, hopefully, doing your homework, take-home test, and even tonight, that most of them are going to be ingrained in your brain anyway, so it's not really going to matter. There is one extra one on your cheat sheet that's not on this slide, and that's number 8. You have tangent inverse plus or minus of infinity is always going to be plus or minus pi over 2. We talked about that earlier, and we'll talk about this. We'll talk about it again. I'll show you in your book. But we did talk about it in chapter 8, I think it was. But we'll go back to it when we get there. The other thing from Cal 1, which is this, that applies with this. Nope, wrong one. If you remember that if you have the limit as x approaches some number of any number over 0, any number over 0 is going to take you to infinity, and that's what we were just talking about. Okay, any number over 0 is going to take us to infinity. Some textbooks, some people on Google say that it does not exist simply because when you're talking about limit, you are talking about highs and lows, and technically you'll never reach infinity. But we're going to say infinity. Okay, so any number over 0 is going to be infinity. I don't care about the direction. In Cal 1, we did do positive infinity and negative infinity. We're not going to worry about that here. And then number 2, any number over infinity, that goes with number 1. Any number over infinity is 0. Okay? So those are the 2 biggies that we're going to be dealing with a lot. Another one is here. At some point in time or another, we are going to get e to the 1 over infinity. And we've already said any number over infinity is going to go to 0. And we've also said anything to the 0 power is 1. So know that that automatically goes to 1. What I want you to do for number 4 is I want you to actually type in the natural log of 0 in your calculator. What do you get? You get a domain error. Why? Well, because of the graph that we talked about. If I draw the graph of the natural log of x, the graph of natural log of x, the y-axis is an asymptote, and you're never going to reach 0. So you can't take the natural log of 0 because the graph, like I said, it's an asymptote, and it gets so close to 0 that it'll never reach 0. So the natural log of 0 is infinity. Technically, you can see it's negative infinity, but we're not going to worry about that. For the same reason, the natural log of infinity, as x goes to infinity, you see what the graph's doing? It's also going to infinity. So make sure you remember that. These are reciprocals of each other. So if I draw the graph of e to the x, the graph of e to the x is going to do this. So again, if you get e to the infinity, as we're moving this way, again it goes up to infinity. Remember this? Negative exponent means reciprocal. And so you get 1 over infinity. Well, that takes you back to number 1. Any number over infinity goes to 0. So a lot of these go hand in hand. You just have to remember them. Okay? And it's a lot, and it's on your cheat sheet, so you're good. Okay, so let's look at this one. If we have a limit as x approaches infinity, if you want to look on your take-home test, and you can look down through those limits on your take-home test. You can see, like, number 11, obviously x is not going to infinity, so that's obviously a L'Hopital rule. Number 12 has an infinity in it, so you'll see what's going on there. 13, no. 14 has an infinity. 15 has an infinity. 18 has an infinity, but it's not a quotient, so we'll talk about that. So kind of recognize what the limits are doing to help you know where you are in your notes as far as your take-home test is concerned. Okay, so in Cal 1, we learned in Chapter 2, so I know it's been a while, so you may want to make a note of this. In Cal 1, when we did limit going to infinity, and that's key, your limit has to be going to infinity. If you have a polynomial over a polynomial, do you remember the rules? There's 3 of them. If your degree is bigger on top, your limit's going to what? We're talking about degrees, so bigger on top goes to what? infinity. Bigger on bottom. Goes to 0. And if they're the same on top and bottom, then you have your leading coefficient over your leading coefficient. Do you remember those? We're talking about the degrees of the polynomials. If it's bigger on top, you're going to infinity. If it's bigger on bottom, you're going to 0. If they're the same, it's leading coefficient over leading coefficient. If your limit is going to infinity, you have got to have this right here in order for these to work. Okay? So, that's Cal 1 stuff. Remember that, because we're going to talk about it in just a minute. Alright, so let's do example number 5. Your limit is going to infinity. So basically, we're asking ourselves, what is the natural log of infinity? Well, if you look at your cheat sheet, what does number 5 say? The natural log of infinity is what? Infinity. And then the square root of infinity, what do you think that is? Yeah, it's infinity. Square root of infinity is infinity. What is that? Infinity over infinity. It's not 1. It's indeterminate. You'll never be able to determine what infinity divided by infinity is. So this is another indeterminate form. I know in basic arithmetic you learn anything divided by itself is 1. So when you're talking about infinity, but when you're talking about infinity, it kind of throws that out of the way, because you'll never reach infinity like you can reach 3. You know. So it's not infinity divided by infinity is not 1. Okay. So what are we going to do? L'Hopital's rule. Yeah. Look on your cheat sheet. Do you see out here? If you get 0 over 0 or infinity over infinity, apply L'Hopital's rule. 0 over 0 or infinity over infinity, apply L'Hopital's rule. So you're going to take the derivative. Well, you're going to have to dig deep, or you look at your cheat sheet, either way. Limit at, or your Cal 1 cheat sheet, that is. Limit as x goes to infinity. What is the derivative of natural log of x? Very good. 1 over x. And what is the derivative if f of x is equal to x to the 1/2? That's the square root of x, right? What is f prime of x? And how would you write that? Right? Okay. So we're going to have 1 over 2 square roots of x. Now, if you want to clean that up, you can. Doesn't really matter to me how you do it. Let's clean it up a little bit. If we do 1 over x times 2 times x to the 1/2, why not? Over 1. Mm-hmm. The negative 1/2 pushes it to the bottom.
Yeah, you don't take it to the
bottom. Okay. So, well, let's look at this. Right now, if we apply the limit right here, you're going to get 1 over infinity, which is what? Any number over infinity is going to be? Let's go back here. Don't erase your paper because I'm going to do it back anyway. 1 over infinity is going to be 0. And down here, you're also going to get 1 over infinity. That's indeterminate, which technically means that you're going to have to do L'Hopital's rule again. That's why I suggest to you to clean it up first and then apply the limit. So let's do this. 1 over x is equal to 2, not equal to, it's times 2x to the 1/2 over 1. Alright, so if we keep going with this, we're going to get 2x to the 1/2 over x. What's going to happen? You're going to get infinity over infinity. But there's something we can do algebraically. Yeah, what is the rule? If I have x to the 1/2 over x to the 1, what is the algebraic rule? You're going to subtract. So we're going to get x to the what? 1/2 minus 1/2. I'm sorry, 1/2 minus 1 is going to be what? So what we're going to have is 2 over x to the 1/2, right? Now watch. If we apply the limit as x approaches infinity of 2 over the square root of infinity, what are we going to get? 2 over infinity, which is what? Any number over infinity is what? 0. And we actually got an answer. Okay. So make sure, if you keep coming up with an indeterminate form, make sure you do as much algebra as you possibly can do, because you might get your answer that way. Now, you can try this if you have a brainiac day that you just want to try this. If you want to take 1 over x over 1 over 2 square roots of x, and you want to apply the L'Hopital's rule again, that's going to be the quotient rule, which is fine. You'll do the quotient rule on the top, quotient rule on the bottom. Personal experience, I'm going to stay away from the quotient rule and do some algebra. To me, algebra is a little more easier than calculus anyway. So, try to get as much algebra out of the way, and then use your calculus. All right, so your answer is going to be 0. Any questions? Okay, let's try this one. Now, what is the limit going to? It's going to 0. The limit for this one is going to 0. So let's see what happens. Well, if we apply the limit as is, always try that first. E to the 0 power we said was what? Anything to the 0 power is 1, almost anything. Plus 1 over 0. So you're going to get 2 over 0. Do you need to apply L'Hopital's rule? No. This is not indeterminate. What is this limit? Any number over 0 for our purposes is going to be infinity because there's an asymptote there. There is an asymptote at 0, which means as that graph comes in, it's either going to go to positive infinity or negative infinity. Regardless, it's going to be infinity. So, like I said earlier, when you start working through, whether it be on the test, whether it be on your homework, whether it be wherever, whatever studying you're doing, try the limit first. Try the Cal 1 purposes first. Because this is not an indeterminate form. Let's try this one. If we plug 5 straight in, so if we plug 5 straight in, we're going to get 5 minus 1, which is going to be 4. Square root of 4 is going to be 2, and 2 minus 2 is going to be 0 on top. No big deal. On bottom, 5 squared is 25. 25 minus 25, that's going to be 0. That is a big deal. So that's an indeterminate form. So let's try L'Hopital's rule. What in the world is the derivative if f of x is equal to x minus 1 to the 1/2? That's your square root of x minus 1. What is f prime of x? What do you have to do here? Chain rule. Very good. 2 people. I'm so proud of y'all. I think that should be bonus points. But neither one of you need them. Chain rule. Chain rule says what? What are we going to do with that 1/2? Bring it out front. What are we going to do inside? Absolutely nothing right now. What are we going to do with the 1/2 on top? You're going to subtract 1, which is going to go to negative 1/2, and then what? Times the derivative of what's inside. The derivative of x minus 1 is going to be just 1, because the derivative of x is 1, derivative of 1 is 0, so it's 1. So there's your chain rule. So if we want to clean this up a little bit, what's it going to look like? What do you get? 1/40 is what you should get. And there's your answer. Any questions on that one? Okay, let's try this one. If we plug 0 straight in, we're going to get 1 minus 1 minus, what did we say sine of 0 was? So that's going to be what, 0? And then, of course, 0 times anything is 0, so that's going to be 0 too. So there's your indeterminate form, which tells me I have to do L'Hopital's rule. So let's take the derivative of the top. Derivative of e to the x is what? E to the x. The derivative of negative e to the negative x, that's going to go to plus e to the negative x. Basically, it just changes the sign. Okay, what is the derivative of negative 2 sine x? Negative 2 cosine x. Now, all of that's addition and subtraction. Actually, it's all subtraction. So you can just take the derivative of each one. But on the bottom, what do you see? That's the product rule. You have x times sine x. So that's your product rule. So you have first times the derivative of the second plus the second times the derivative of the first.
2 sine x is not, but the derivative of 2 sine x is not product rule.
Well, it is, but when you take the derivative of the 2, it goes to 0, so we just pull it out as a constant. But we can't do that with x because the derivative of x is actually a number. On the bottom, if it was a 2 sine x instead of an x sine x, yeah. You just pull the 2 out and do the derivative of the sine. Basically, if you have polynomials, variables, you have to do the product rule. Alright, that's not going to clean up that much. So let's just leave it alone and see what happens. Okay. E to the x, e to the 0 is going to be 1 plus 1. And then the derivative of cosine is what? 1 times negative 2 is going to be negative 2. What's that? What happens there? You're going to go to 0. And that's not a big deal. Guys, if you get 0 on top, that's not a big deal. It's when you get the 0 on the bottom with it. That's when it's a big deal. Alright, on the bottom, 0 times anything, x times cosine x, 0 times anything, which doesn't matter. It's going to be 0. And then sine of 0, what did we say sine of 0 was? So we got it again. Who diddly do? Now what? Do it again. So let's apply L'Hopital's rule again. Alright, again. The derivative of e to the x is e to the x. Derivative of negative e to the negative x is going to be negative e to the negative x. Derivative of negative 2 cosine x. What are you going to get? Good. Plus 2 sine x. Good job. Okay. On the bottom, when you see that x cosine x, what is that telling you to do? That's the product rule. Okay? This is the product rule, and this is the product rule. Just for the x cosine x, not the sine x times 1. Just the x cosine x. So we're going to have first times the derivative of the second plus the second times the derivative of the first, which is just 1, so we don't even have to worry about it. And then the derivative of sine x, of course, is cosine x. Okay, let's apply the limit again. So if we plug in 0 everywhere we see an x, we're applying the limit. We're going to get 1 minus 1 plus 2, right? No. 0. Over, which that's going to be 0. Alright. This is going to go to 0. Cosine of 0, what did we say cosine of 0 was? 1 plus 1. So you get 0 plus 1 plus 1, which is going to be 2. What's the answer? 0. Now, what if you don't know what sine of 0 is? Calculator. All you have to do is hit sine of 0. What if you don't know what the natural log of 0 is? Calculator. Okay? If you don't know off the top of your head what these sines are and what these cosines are, plug it into your calculator. Okay? So don't panic on that. Any questions on L'Hopital's rule? Indeterminate forms. Indeterminate forms, we've talked about 2 of them. 0 over 0 and infinity over infinity. Anytime you have a quotient and you apply a limit and you get 0 over 0 or infinity over infinity, apply L'Hopital's rule. Okay? Now, we are going to talk about other indeterminate forms. Like I said, we've talked about 2. Infinity over infinity and 0 over 0. If you get those, apply L'Hopital's rule. Well, what happens if you don't have a quotient? What happens if you have a product? What happens if you have a product and you get something that looks like this, or you could even get this? Those two mean the exact same thing. Okay? So this is another form. This is your products. Instead of dealing with a quotient, we're dealing with a product. So if you have 2 things, 2 functions multiplied together, and you apply the limit to that product, and you get 0 times infinity or infinity times 0, it doesn't matter. What you're going to do is you're going to change your 2 functions into either this or this. Now the question is, well, which one do you do? The best suggestion that I can give you is this. If you change your function, either one of your functions, to the denominator, you're going to have to divide by the reciprocal, which makes it into a quotient. Okay? For example, if you choose to go with this one, that's fine. You're going to put this function, your first factor, on top, and then you're going to do 1 over your second factor on bottom. Now this is a quotient. And then look, it says apply L'Hopital's rule. Do you want to do the quotient rule? If at all possible, we do not want to do the quotient rule. Okay? So, my hint to you is this. Do a little bit of forward thinking before you go either with this one or with this one. Whichever one you put on the bottom, you want it, here's my words, whichever one you put on the bottom, you want it to be easy to find the derivative. Okay? Whichever one you put on the bottom, you want to be able to easily find the derivative. If you can't easily find the derivative, you probably picked the wrong one. Natural log, I'm never going to put natural log on. I won't say never. Rarely will I ever put natural log on the bottom. Rarely. Okay. So, if you have a quotient, let's review. If you have a quotient and you apply a limit to a quotient and you come up with 0 over 0 or infinity over infinity, you're going to apply L'Hopital's rule. If you have a product and you come up with 0 times infinity or infinity times 0, the first thing you need to do is you need to try to apply the limit. And if you apply the limit and you come up with 0 times infinity or infinity times 0, then you need to change it into this form. You need to change it into your quotient. From here, simplify, of course, but apply the limit again. And if you apply the limit again, once you get it in this form and you come up with the indeterminate form of 0 over 0 or infinity over infinity, then you're going to go to L'Hopital's rule and apply the limit again. So you're applying the limit 3 times. Number 1, apply the limit straight up, just like we did in Cal 1. If you come up with the indeterminate form, then change it to one of these two and apply the limit again. If when you apply the limit, you come up with 0 over 0, infinity over infinity, apply L'Hopital's rule and apply the limit again. Okay? So you keep trying these new techniques until you come up with an actual answer. So let's try it. Let's go with this one. You have your limit as x is approaching infinity. I'm sorry. No, it's not. As x is approaching 0, what does that plus sign mean? Haven't seen it since Cal 1. It's approaching from the right. What if there was a negative sign? It'd be approaching from the left. Okay? Again, directional, we're not really going to focus in on directional. It just kind of helps you know which way the graph is going. Okay? Which way we're approaching. So, you have the limit as x approaches 0 from the right of x squared times ln x. This is a product. X squared times ln x. Okay? So the first thing I want you to do is I want you to actually apply the limit as is. So if I apply the limit as is, of course 0 squared is going to be 0 times. Now, look on your cheat sheet or plug it into your calculator. Either way, it's going to get the same answer. You're going to get the same answer. Tell me what the natural log of 0 is. On your calculator, it comes up with domain error, which means you're either going to infinity or negative infinity. Your calculator will not do infinity. Okay? So if you get a domain error, that just means that you're going to infinity. Or if you look on your cheat sheet, it tells you that the natural log of 0 is negative infinity. Again, we don't care about the negative infinity. We just care about the fact that it is infinity. Okay? So, we applied the limit, and we came up with one of our indeterminate forms. We came up with 0 times infinity. What was the next step? You're going to change it. So now we're going to apply the limit as x approaches 0 from the right. And we have to decide. Now look, this is your f of x. And this is your g of x. Those are your two functions. You have two functions and you're multiplying them together. So we have to decide which one's going to go on top and which one's going to go on bottom. I gave you a huge hint a while ago. What did I tell you? I will rarely, if ever, put a natural log on bottom. Rarely, if ever. So you know my natural log, the g of x, is going to go on top. So on bottom, what are we going to have? Don't forget the 1 over part. You're going to do the reciprocal. 1 over x squared. What are we going to do now? Are we going to go straight to L'Hopital's rule? We're going to apply the limit again. Okay? Apply the limit initially. If you come up with an indeterminate form, then change it to a quotient by dividing by the reciprocal. Apply the limit one more time. The natural log of 0 is what? That's on your cheat sheet, or plug it into your calculator, either way. The natural log of 0 is infinity. And then 1 over 0, any number over 0 for our purposes, is not undefined. It's what? It's infinity. So does that look familiar to you? That's an indeterminate form. Infinity over infinity tells me to do what? L'Hopital's rule. L'Hopital's rule. So let's do this. So we're going to have limit as x approaches 0 from the right. What is the derivative of natural log of x? 1 over x. Okay. If you have a function, this is Cal 1, of 1 over x squared, and I want to know what the derivative is, what's the first thing I'm going to do? Hopefully you're going to change it with a negative exponent, okay? I mean, you can apply the quotient rule, but to me, I think it's easier to use the negative exponents. Plus, that's usually the first thing I'll think about doing anyway. So what is the derivative of x to the negative 2? Right? Multiply your power is opposite of the antiderivative. Of antiderivative y'all to death, and now the derivatives are kind of losing their way. But the derivative of x to the negative 2, multiply the power out front. So you have negative 2 times, and then lessen the power by 1. Negative 2 minus 1 is a negative 3. How do we write this? It's going to be negative 2 over x to the third. Okay, so we applied L'Hopital's rule. Are we going to apply the limit? If you do, you're going to get infinity over infinity again, right? Because look at it. You have 1 over 0, which is infinity on top, and then you have negative 2 over 0, which is infinity on bottom, so you still have your indeterminate form. So what can we do? Multiply by the reciprocal? Snotty poopers. Okay. So we're going to have x to the third over negative 2. What happens? So we're going to have x squared over negative 2. Now apply the limit. You're going to have x squared over negative 2, which is going to be 0 over negative 2, which is what? All that. I have had students before in this particular chapter go down through on their test and put 0 and infinity. 0 and infinity. Because they didn't know how to do it. They didn't do very well, but I'll say you got to give it a try. Okay. Now what I want you to do is I just want you to think. What would happen if right here, when I changed the form, if I had have done x squared on top and 1 over the natural log of x. If x squared was on top, you'd have 0 over 1 over infinity. Any number over infinity is also 0. So you get 0 over 0. So you're still going to get the indeterminate form. Then you would have to apply L'Hopital's rule. L'Hopital's rule to x squared is not that bad. It's just 2x on top. But the derivative of the natural log of 1 over x is going to be 1 over x, and then you have to go through it again. So, actually do the quotient rule, which is horrible. So just think about it. All right, let's go here. I know you'll love when I give y'all pi over 2s and all that, but you can deal with it. You'll be fine. Okay, so let's apply the limit straight up. So if we plug pi over 2 here, we're going to get 2 times pi over 2. What are you going to get? You're going to get pi minus pi, right? Which is 0. Do this for me. In your calculator, you know how to do secant in your calculator? What is secant? 1 over cosine. So in order to do secant of pi over 2, depending on how your calculator works, I have to do cosine of 0, then close the parentheses, and then hit my x to the negative 1 button. And it tells me divide by 0 error. Which means if you're dividing by 0, we're going to infinity. So we get the indeterminate form of 0 times infinity. Make sure before we move any further, I'll leave this infinity. Alright, so we have 0 times infinity. And when you get 0 times infinity, what's the next step?
When you said the inverse button, you just meant the 1 over
X to the negative 1 or 1 over x, yeah. Whichever one you have. Okay, so which one do you want to put on top? And which one do you want to put on bottom? Do a little bit of forethinking and think about what this is going to look like. If I leave secant x on top, what's the derivative of secant x? Secant x, tangent x. Oh my. It's okay, I mean we can do 90 degrees, that's not that big of a deal. Over 1 over 2x minus pi. How are you going to do the derivative of 1 over 2x minus pi? Well, you can do chain rule or quotient rule, whichever one you want to do. Either way, it's going to be crazy. Watch this. If I leave 2x minus pi on top, and on the bottom I do 1 over secant x. What is 1 over secant x equivalent to? Isn't that nice? Let's do that. So we're going to have limit as x approaches pi over 2 from the left. We're going to leave the 2x minus pi on top. And on bottom, technically you're going to have 1 over secant x, but 1 over secant x is the same thing as cosine x. Isn't that wonderful? Apply the limit. Don't take the derivative automatically, because you may not get an indeterminate form. Apply the limit. If we apply the limit on the top, we already know that if we plug pi over 2 in for x, we're going to get pi minus pi, which is going to be 0. What's cosine of 90 degrees? Is 0 also. So we do get the indeterminate form, and we are going to have to apply L'Hopital's rule. So let's go there. So what's the derivative of 2x? What's the derivative of pi? 0. Pi is a number. It's 3.14 blah, 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 blah. It's a number. The derivative of any constant is 0, so the derivative of pi is 0. Over. What's the derivative of cosine x? So we're going to get 2, applying the limit now. We're going to get 2, which is good, over what? What is sine of pi over 2? Sine of pi over 2 is going to be 1, but you have the negative, so we're going to get negative 1. So we're going to get what? Negative 2. Again, what if you don't know what? Please tell me you know what pi over 2 is. You can change pi over 2 to degrees either by using your unit circle or by multiplying by, what, 180 over pi? Either way. But you need 90 degrees in order to plug it into your calculator. So sine of 90 degrees is going to shoot 1 at you, and then times the negative is going to be negative. So negative 2 is actually your limit. Questions? Try it. Now we're going to infinity. We are going to infinity. So let's discuss this, okay? If we apply the limit straight in, this is x times sine of 1 over x. So if we plug infinity in, we're automatically just going to get infinity for that x, right? Now watch this. You ready? This is going to be sine of 1 over infinity. What is 1 over infinity? What is any number over infinity? 0. What is sine of 0? How do you know? Calculator. Sine of 0. Put it in your calculator. Let's make sure sine of 0 is 0. All right, so you get an indeterminate form. So since we have an indeterminate form, what are we going to do? Okay, so what do you want to go on top? I would say sine of 1 over x. So on bottom, what are you going to get? 1 over x. Don't forget to change that. Let me give you a heads up on this one, okay? Right here, and I don't know why this happens, but apparently I have not ingrained it into your heads enough. You cannot cancel the 1 over x's. You cannot cancel the 1 over x's. Sine of 1 over x, 1 over x is an argument in your trig. It is not a coefficient. Do not cancel. Okay. Maybe that's ingrained enough. I don't know. Let's apply the limit, though. If we apply the limit now, sine of 1 over x, sine of 1 over infinity, 1 over infinity goes to 0, and sine of 0 is 0. Over 1 over infinity is still 0. So we get the indeterminate form. Now what? Derivative. L'Hopital's rule. Derivative. What is the derivative of sine of 1 over x? What if f of x, we're going to have to do this in a minute anyway. If f of x is 1 over x, what is f prime of x? What's the first thing you want to do? Ooh. Question. I knew, because I practically screamed it at you, that I cannot cancel this 1 over x with this 1 over x because this 1 over x is an argument and this is an actual constant. Can I cancel this negative 1 over x squared with this negative 1 over x squared? Yes. This is not part of the argument. The only argument here is 1 over x. This is not part of the argument. In fact, I could move that out front if I wanted to as a coefficient. So technically, that is a coefficient. And so instead of doing all this algebra, I can just cancel this. And so what I'm going to get is limit as x approaches infinity of cosine of 1 over x. Apply the limit again. What is 1 over infinity? 0, and what is cosine of 0? So if you went down through there on your test and you put in 0, 0, 0, 0, 0, then you get an answer. The answer is 1. Alright, let's take a break and then we'll talk about the other forms. Talked about forms of indeterminates. We talked about the 0 over 0, we talked about infinity over infinity, we talked about 0 times infinity. So we talked about the quotients and we talked about the product. Now let's talk about the powers. So these are your other indeterminate forms, and we call these the power forms. And I don't know if that's on your cheat sheet. It doesn't really matter, but when you apply a limit and you come up with one of these forms, either 0 to the 0, and because earlier we talked about when you think to the 0 power is 1. Well, when you have 0 to the 0 power, that's a little impossible. So 0 to the 0 power, it's indeterminate, it is not 1. 1 to the infinity, you would think, well, that's infinity. No, it's not. It's indeterminate. And infinity to the 0 power is not 1. It's indeterminate. So these are your power forms. Now, with the power forms, they're not hard. They're just a lot of steps, a lot of things that you've got to do, okay? So what happens is this. If you have a limit, and look at this, you have two functions here. One is actually your base, and the other one is actually your exponent, okay? So you have one function that is a base and the other function that is an exponent. If you have a limit that is being applied to a power, and you come up with an indeterminate form of one of these three, since we're talking about exponentials, the inverse, whatever goes hand in hand with the exponentials, is your natural log. So remember back in 112, when we were talking about exponentials, you would do logs and natural logs, same thing. So what's going to happen is this, is if we apply the limit to a power and we come up with one of these indeterminate forms. Now it's very important to apply the limit because you may not come up with one of these forms. But if you do come up with one of these forms, what we're going to do is we're going to take our function and we're going to apply the natural log to both sides. So basically what we're going to be working with is the right-hand side, so don't really worry about the left-hand side. So we're going to take this and we're going to apply the natural log. Now, if you have something like, I don't know, x to the 5th power, and you apply the natural log to it, do you remember your log power, or your power log rule? What can you do? Do you remember that? So now what we're going to do is when we apply the natural log, for our purposes, to the right-hand side, what's going to happen is you're going to apply the limit to your power, because remember we moved the power out front, natural log times your base, or natural log of your base. Okay, and this is what we're going to work with. Now look at what you have here. You have a product. You know what happens when you have a product. That's when you go back to your product series. So we're going to go through this and we're going to come up with an answer. But when you come up with an answer, you have to remember that you apply the natural log. When you apply the natural log to a limit, this is what your answers are going to look like. Okay? If you come up with a number, that's what L means. The limit is actually a number. So if we come up with capital L is equal to like 3, that's not your answer. Your answer is going to be e to the L, e to the 3, for example. Okay? If you come up with infinity, your answer is going to be infinity. If you come up with negative infinity, your answer is going to be 0. All right? So make sure you remember these. Okay, so let's try this. And again, you have your formulas page that tells you the steps. It's a little confusing, so that's why I went through it for you. All right, so if we have the limit as x approaches 0 from the right of all of this. Again, remember, this is your function. This is f of x, and this is g of x. Okay? So you have a base to a power. Let's apply the limit and see what happens. If we apply the limit on the inside, we're going to get 1 plus 0, right? 1 plus 0, which is going to be 1. And then for our power, we're going to get 1 over 0. What is 1 over 0? infinity. Okay? So what we're going to come up with is 1 to the infinity. Is that one of your power forms? 1 to the infinity is one of your power forms, absolutely. So, if you come up with one of your power forms, what you're going to do now is you're going to apply the limit as x approaches 0 from the right. So you're going to apply the limit, and then you're going to take your power. You're going to use your log rule. Okay, you're going to take your power and move it out front. Times, and I'm not going to write them, well, I guess I can. Times, just to make sure you know, times the natural log of your base. And then you're going to apply the limit again. Okay? So all we've done is this. Watch. We applied the limit initially and came up with one of our power forms. Since we came up with an exponential, we have to take the natural log. Okay? Since you came up with an exponential power form, then you have to take the natural log. So we're going to apply the exact same limit, use the power rule, times the natural log of the base. And now we're going to apply the limit one more time. So if we apply the limit again, like we said, we have 1 over 2x, or 1 over 0. And 1 over 0 is going to be infinity, right? Times the natural log, 1 plus 0 is going to be 1. What's the natural log of 1? If you don't know, put it in your calculator. Natural log of 1 is going to be 0. Does that look familiar? That's your product power, or your product rule. So since you have infinity times 0, that's going to be your other form. That's your product form. When we come up with the product form, what are we supposed to do? Yeah. So apply the limit again. All right. So which one do you want to go on top, and which one do you want to go on bottom? There's a huge hint here. Natural log needs to go on top. Now let me ask you this. If we put 1 over 2x, that's what we're supposed to do, right? You're supposed to do 1 over, in this case it's going to be g of x. If we do 1 over g of x, 1 over 1 over 2x is going to give you what? 2x. So that's nice. Now let's apply the limit again. We know that if we plug 0 in for the top, you're going to have the natural log of 1, which we said was what? 0, over 2 times 0, which is 0. Well, it's not. You got an indeterminate form again. But this time it's a quotient. When you have an indeterminate form for a quotient, what do? The derivative, L'Hopital's rule. Yep. You're going to do the derivative. So, limit as x goes to 0 from the right. Now, let's take the derivative of the top. The derivative of natural log of 1 plus 3x. What's the derivative of natural log of u? It's going to be 1 over u, which we know is u is 1 plus 3x, times what? Times the derivative of u. What's the derivative of 1 plus 3x? 3. All right, so we have 1 over u du. That's the derivative of the natural log u. And then the derivative of 2x is what? It's just 2. I mean, at this point, you can clean this up and get a complex fraction if you want to, but honestly, it's not going to clean up that much. You can try to clean it up, but either way, let's go ahead and apply the limit. If we apply the limit, you're going to get 1 over, watch this. We're going to plug 0 in everywhere we see an x, so we're going to get 1 over 1 plus 0, which is going to be what? 1 times 3 is going to be 3. Can't do anything with the 2, so you get 3 halves. So you finally get an answer. So what you're going to have to do is you're going to apply the limit. And if you come up with an indeterminate power form, then do the rule. Go through and take the natural log of both sides and apply the limit again. If you come up with another indeterminate form, which in that case it would be the multiplication indeterminate form, then apply the multiplication rule, which says to do f of x over 1 over g of x or g of x over 1 over f of x, whichever one. Then apply the limit again. You may get another indeterminate form. This time it would be a quotient, which tells you to do L'Hopital's rule, and hopefully you'll come up with an answer eventually. Okay? But just please remember at each step, apply the limit. Okay? Because that's what's going to tell you when to stop. When you apply the limit and you actually come up with a good answer, that's going to tell you when to stop.
So pretty much if you have an X at the top and the bottom, then probably not be ready yet, right?
Depending on what if your limit's going to 0 or infinity, yes. But if your limit's going to an actual number like 1, 2, whatever, probably not. But if your limit's going to 0 or infinity, probably. You're probably going to get one of those indeterminate forms. And on your take-home test, for example, number 11, that's going to 1, so you have to figure out what's going on there. The rest of them were either going to infinity or 0. Which, number 11 is a quotient, so you automatically should know L'Hopital's rule. Alright, so let's look at this one. You have limit as x is going to infinity. Let's go ahead and apply the limit and see what happens. So we have 1 plus e to the infinity. If you go back to your formulas page, we said that e to the infinity is what? E to the infinity, because that's what we have, 1 plus e to the infinity. Well, what is e to the infinity? It's infinity, and 1 plus infinity is going to be what? Still infinity. Anytime you're using infinity and you're not going to get infinity as the answer is if you have infinity over infinity, which is indeterminate, or if you have a number over infinity, which is going to be 0. Okay, so you have infinity. So if we do e to the negative infinity, e to the negative infinity, doesn't matter about direction. Actually, on this one it does. E to the negative infinity, you're going to get 0. That comes off of your formulas page. Alright, so we have our product indeterminate form. When we get our product indeterminate form, what does it tell us to do? Oh no, that's not a product. That's a power. Sorry. So what do we get this time? Infinity to the 0 power. Is that one of our indeterminate forms? Yes. You're going to get infinity to the 0 power, which is one of your power forms. If you get a power form, that tells us that we have to take the natural log. So let's go limit as x approaches infinity. Move your power out front. So we'll have e to the negative x times the natural log of 1 plus e to the x. And let's apply the limit one more time. If we apply the limit one more time, e to the negative infinity is going to be what? 0. And then the natural log, what did we say? 1 plus e to the negative, or e to the infinity? What is that going to be? Infinity. Just look at the previous step and it'll tell you what it is. Alright, so you have 0 times infinity. Is that one of your indeterminates? Yes, that one is your product. So what does it tell us to do? What is the product form? What does it say do? Look on your cheat sheet. What does it say do? It's on top of your power forms. What do we do? Yeah, you're going to have to make it into a quotient. You're going to have to make it into a quotient. So you're either going to do f of x, which, now look, this is f of x. And this is g of x. Okay? So what do we not want on the bottom? Typically. Typically, we don't want that ln on the bottom. So let's do ln of 1 plus e to the x over 1. Well, let's go over here. Watch this. If we do 1 over e to the negative x, because that's what we're going to have. What is 1 over e to the negative x? Right. If you have a negative on the bottom, you push it to the top. Negative on top, you push it to the bottom. So that's good. Let's apply the limit one more time. Again, if we plug infinity in, 1 plus e to the infinity is going to give us what? Infinity. But what's the natural log of infinity? Natural log of infinity is infinity. So we're going to get infinity on top. What do you think we're going to get on bottom? E to the infinity is going to be infinity again. So there's another indeterminate form. This time we have a quotient. What does the quotient of an indeterminate form tell us to do? I spell L'Hopital. Alright, which means we're going to have to take the derivative. Okay, so the derivative of the natural log of u. What's the derivative of natural log of u? 1 over u, which you know u is 1 plus e to the x, right? Times what? The derivative of u, which is going to be e to the x. Okay. Oh, good question here. Can I cancel the e to the x's right here? No, because on the bottom, that's a group. 1 plus e to the x, that's a group. The only time you can cancel out a group is when you have another group just like it. And we don't. Okay. And then on the bottom, the derivative of e to the x is what? Well, can I cancel out those? Yeah, I can cancel those out. So now we have the limit as x approaches infinity of 1 over 1 plus e to the x. All right, so let's apply the limit. What are we going to get? 1 over what? If we plug infinity into e to the x, what do we get? E to the infinity is infinity, and infinity plus 1 is infinity. Look on your cheat sheet. What is any number over infinity? Any number over infinity is going to be 0. Is this your answer? Why? You apply the natural log. When you apply the natural log, you've got to go back in terms of e. Got to go back in terms of e. Okay, so how do you know on your cheat sheet, how do you know which one to use? When it says conclusions, am I going to use 1, 2, or 3? Well, at this point, if you get a number that is not infinity, if you get an actual number, then your answer is going to be e to that number. So, our log is equal to 0. Therefore, not our log, our limit. Our limit is equal to 0. Therefore, our new limit is e to the 0. But e to the 0 is equal to what? That's your answer. Just remember, anytime you have to do the power rule, anytime you have to do the natural log, you have to go one more step. Don't forget your e's.
The natural log and get an answer. You're always going to have to go back to
Well, again, it just depends on what your limit is going to. It just depends on what your limit is going to. And the reason I say that is because when you apply the limit, The only time you're going to keep going is if you give an indeterminate form. So like on this one right here, if our limit was going to 0, if our limit hadn't been going to 0, we would have had 1 plus 1, which is 2 to the first power, which is 2. So we wouldn't have to go any farther. Not necessarily. Alright. Oh, trig. Okay. I don't think we've seen this one yet. Let's see what happens here. If we apply the limit as x approaches pi over 2 from the left. Now what is pi over 2? 90. What is secant of 90 degrees? Put it in your calculator if you don't know. What is secant of 90 degrees? What'd you come up with in your calculator? You should come up with an error. When we come up with errors, what does that mean? Infinity. What is tangent of 90 degrees? That's going to be infinity again. So what we're going to have is infinity minus infinity. Okay, when you come up with infinity minus infinity, a lot of people will say, well, infinity minus infinity is 0. I would argue that infinity minus infinity is infinity. I would also argue that it's indeterminate because we can't determine the limit if it's infinity. So this is another indeterminate form. Okay? If you get infinity minus infinity, this is going to be another indeterminate form. So what are we going to do? If you have, look, this is f of x minus g of x. If you have this, if you have a difference, a limit of a difference, typically what you can do, and from Cal 1, what we did is we applied the limit to the first function, then we subtracted the limit of the second function, and we came out with an answer. Well, this time we get infinity minus infinity, and it's just not going to work. So, when this happens, what you want to try to do is you want to try to make your difference into either a quotient or a product. Okay? So we're going to try to play around with some trig and try to get this into either a quotient or a product. Because if it's a quotient or a product, we know what to do. Right? Right now, we don't know what to do with infinity minus infinity. So let's do some trig. What do you think? Secant x. What can we do with secant x? 1 over cosine x. What about tangent? Well, you have 2 fractions that have a common denominator. What can you do when you have 2 fractions with a common denominator? You can put them together. So this is what we're going to do. We're going to do the limit as x approaches pi over 2 from the left of 1 minus sine x over cosine x. Let's apply the limit and see what happens. What is sine of 90 degrees? And 1 minus 1 is what? 0. What is cosine of 90 degrees? And there you have it. Yeah, I agree with indeterminate form. Okay. So, which indeterminate form do I have? The quotient, which tells me to do what? Hospital. L'Hopital. The derivative of the top, the derivative of the bottom. Think of it. So let's do the derivatives. Limit as x approaches. The funny thing about that, Amanda, is if you Google L'Hopital, some French enunciations spell it as hospital. It's funny. Okay. Anyway, derivative. Derivative of 1 is going to be 0, so that's the derivative of sine x. You do have a negative there, so you're going to have negative cosine x. The derivative of sine x is cosine x, but you have the minus sign there, so you have to do minus cosine x. And then the derivative of cosine x is negative sine x. So they're going to turn out to go away anyway, but still. Now, let's apply the limit again. Cosine of 90 degrees is going to be 0. Sine of 90 degrees is going to be 1. So what's your answer? The answer for this one is going to be 0. Okay. Do I have to go back and apply the E? Well, you didn't do natural log. Very good. Just thought I'd throw that in there. Okay. So just remember, if you have a difference, now, understand, Cal 1, we applied limits. That's my voice. In Cal 1, we did apply limits to differences. You just did the limit of 1 minus the limit of the other one. The only time you're going to do this is if you get infinity minus infinity. If you get infinity minus infinity, you have to turn it into a quotient. Okay? You have to turn it into a quotient. I'm going to take home test. I did not do that to you. Yeah, you don't have to do that. But when you do the homework, if you do the homework with bonus points, you will come across one of those.
I have a question on the, when we take the derivative, we're not taking the derivative of the whole thing, we're just taking the derivative of the top and the derivative of the bottom. I'm saying that taking the derivative of the whole thing would be doing the quotient rule, right?
Yes, yes. You're taking the derivative of what you have is f of x over g of x. L'Hopital's rule says to take the derivative of the top and the derivative of the bottom. So, yes, you are correct. If you took the derivative of the whole entire thing, you would be doing the quotient rule, which would be nasty. Good question. Anything else? Okay, so all the indeterminate forms, are we good with them? You have 0 over 0, infinity over infinity. You have your product form. You have your quotient forms. You have your product form. You have your product forms. And you have your infinity minus infinity. You have your difference form. Now there's 4 of them. The difference form is not on your cheat sheet. You can write it on there if you want to.
All you do is change. You just have to change the trick.
You have
Is there any other way to do that?
If you come up with a difference form, your goal is to you want to turn those are infinities because you have a constant. You want to turn f of x minus g of x into either a product or quotient. And you're going to do that by using trig identities or straight up algebra. Better? Anything else? Alright, so let's leave, well, we won't be leaving them. Let's go to integrals. look at the title of this. We're doing integrals. Y'all know what integrals look like, right? This is an integral. What's another thing for an integral? Another word for integral? Antiderivative. With infinite, what does that mean? We're going to have boundaries, and one of your boundaries is going to be infinity. Okay, baby. Okay, with infinite limits of integration. So basically that big long title means that we're going to have integrals, antiderivatives, that have as one of your boundaries infinity. Infinity is either going to be your top boundary or your bottom boundary. Technically this would be from negative infinity to b, or a to positive infinity. Okay? So, what do you do? Well, when we talk about integrals, we're talking about summations. We're talking about the summation, the area under a curve. Do you remember that from Cal 1? When you do an integral, when you do an antiderivative, we're talking about area under the curve. Well, if you remember, we briefly in Cal 1 talked about how you add up those rectangles to find the area under the curve. Raymond's sum, briefly talked about that. When you talk about Raymond's sum or a summation, you're actually talking about a limit, okay? So what we're going to do is this. Watch. Remember on the previous slide I told you that you had one of two things going on. Either one, you're going to have a number to infinity of a function. If you're trying to find the antiderivative or the integral from a number to infinity, this is what you're going to do. And basically what you're doing is you're taking the infinity out of play, and you're going to do this integral. And when you apply the integral, you're going to have a t into your function, and then you're going to turn around and apply the limit. Okay? So you're going to rewrite this, taking the infinity out of play by putting it into the limit. So you're going to do the limit as t goes to infinity of a number up to t of your function. Then you're going to take the antiderivative of your function. You're going to plug your boundaries into that antiderivative and then apply the limit. Okay? All of this in Cal 1. So what are you going to do? Either one of these, it doesn't matter. When you see infinity as your boundary, what you're going to do is you're going to apply the limit as t goes to whichever infinity you have, positive or negative, and then you're going to replace your infinity in your original integral with t. And then you're going to do the actual antiderivative, plug your boundaries into your antiderivative, then apply the limit. Now, what happens if I get from negative infinity to positive infinity? What happens if I do this? Well, what you're going to do, what's the midpoint from negative infinity to positive infinity? 0. So what you're going to do is you're going to bust it up. You're going to go from negative infinity to 0, which is this one, plus 0 to infinity, which is this one. Okay? So if your boundaries are all real numbers from negative infinity and positive infinity, you're going to bust it up. Now, this is extremely important. Okay? So if you don't have my PowerPoints, make sure you write this down, because this is what your answers are going to look like. When you have a problem like this, you can look on your take-home test to see. It's going to be Roman numeral number 3 on the back. Look at what it says. It says evaluate the following integrals and tell whether they converge or diverge. If they converge, then give the sum as well. What does that mean? Well, when you apply these limits, you're either going to get a number or you're going to get infinity. If you get a number, then your answer is going to be, let's say you got 3. Okay? Let's say that you did the integral and you applied the limit and you came up with 3. Your answer on your answer sheet is going to be it converges to 3. Converges to 3. Because what's going to happen is this, is you'll have something like that, and let's say that you have this. And let's say that A is 1. So we're trying to figure out what's going on. It's converging as we get closer and closer to infinity, right? So what's happening, it happens is you get a convergence, and your answer would be something like converges to 3. Okay? What happens if it diverges? Well, if it diverges, the limit does not exist. That's when you will get either does not exist, infinity, or negative infinity. And it just diverges. And that's your answer. Your answer is diverges. Okay? Now, look at this. If the integral is broken into 2 different integrals, in other words, if you're having to apply this rule here, both parts must converge. So, for example, if you do this one and it diverges, the whole thing diverges. You don't even have to do the second one. If the first one converges and the second one diverges, the whole thing diverges. However, if the first one converges, let's say at 3, and the second one converges, let's say at 2, then the whole thing converges at 5. 3 plus 3 plus 5, because you're adding. Okay? Alright, so let's try this. So look at what you have. You have an integral from 2 to infinity. So do you know which rule you're going to use? First, second, or third? The first one. A is 2 for your rules. So you have A to infinity, 2 to infinity. Your function is 1 over x minus 1 quantity squared, and of course dx. So let's rewrite it. So we're going to do, watch this, we're going to do the limit as t goes to, and you're using the first one, so t goes to infinity, of the integral, and we're going to replace infinity with that t so that we can do the antiderivative without having to worry about the infinity, of your function. Okay? So do you see what I did? I just wrote it as a limit, taking infinity out of my integral so that I could actually do the antiderivative without applying infinity initially. Okay, so from here, once you rewrite it in this form, your next step is to actually do your Cal 1 antiderivatives. That's stuff that you learn how to do in Cal 1. So, can you tell me how to find the antiderivative? Can you tell me how to integrate, however you want to look at it, 1 over x minus 1 quantity squared? U substitution. What is u going to be? And what is du going to be? Dx. Is that what we need? Yeah, so we're good. So this is going to turn into the limit as t goes to infinity, which we're not going to touch until the very end, of the integral from 2 to t of 1 over what? U squared du. Okay, let's keep going with Cal 1 stuff. How am I going to integrate 1 over u squared? I can't integrate a quotient. Very good. Well, what is the antiderivative? What is the antiderivative of u to the negative 2? Okay, let's stop right here. Watch this, because a lot of you are still confused on this. Why in the world did I move my integral with the boundaries to a integral symbol anymore? The integral symbol tells me to take the antiderivative. Well, I did that, did I not? The antiderivative of u to the negative 2, you add 1 and divide by the new exponent. So there's the antiderivative. That's what that symbol told me to do. So since I did what that symbol told me to do, that symbol's gone. So now I have to put those boundaries somewhere. I can't just throw those boundaries out. That's why we move it over here and put our boundaries there. Now, like we talked about earlier, you can either change your boundaries in terms of u, but I think for these purposes, it's easier just to go ahead and put u back in. What did we say u was? But let's go ahead and fix it, okay? We're going to have negative 1 over x minus 1, right? Do you see what I did? U to the negative 1 over negative 1 is the same thing as negative 1 over u. Okay, not finished yet. Why in the world did I put a division symbol right there? Okay, anyway. Okay, here's another Cal 1 question. When I actually apply my boundaries, when I actually plug my boundaries in, it's something minus something. Can you tell me which minus which? Top minus bottom. Top minus bottom. So we're going to have negative 1 over t minus 1 minus negative 1 over 2 minus 1. Okay, can we do anything with a negative 1 over t minus 1? No. What about negative 1 over 2 minus 1? What is that? Well, what's 2 minus 1? 1. Negative 1 over 1 is what? Negative 1, but you have negative at front, so what does that turn into? Plus 1. Now, the whole integration is gone. Do you see that? Every single bit. We started out with this nasty stuff. We did our u substitution. We fixed it into a form that we actually can integrate. We integrated, and then we did our boundaries. So all of that integral stuff is gone. Now all we have to do is apply the limit. Everywhere you see a t, we're going to plug in an infinity. So applying the limit, we're going to get negative 1 over infinity minus 1 plus 1, which is negative 1 over infinity. What is anything over infinity? Anything over infinity is 0. Plus 1 is 1. On the answer blank, what are you going to put? Because the directions say evaluate the following integrals and tell whether they converge or diverge, and if they converge, then give the sum as well. So on the answer blank, let's just pretend that this is number 21. What are you going to tell me? Good, right. Better. Maybe that's more legible. Converges to 1. And that's your answer. What does that mean? That means underneath this curve, if I were to graph 1 over x minus 1 quantity squared, which you can imagine what that looks like, and my boundaries were from 2 all the way to infinity, that means that I could get 1 good square. Because if you think about it, as it gets closer and closer out, it gets closer and closer. So that square is going to be tiny, tiny, tiny.
How do you know it converges?
Because I actually got a number.
Okay.
If you actually get a number, it's going to converge. If you get infinity or does not exist, it diverges. A number tells me that it's going to converge. Anything else? Okay, let's try this one. All right, so we look at your boundaries. We're going from 2 to infinity, so which one are we going to use? First, second, or third? The same one. So we're going to rewrite this as a limit. So your limit as t goes to infinity. Do you see how I'm using the cheat sheet? I've actually got my hand on it, copying it verbatim. Okay, that's what you need to do. Of your integral, and we're going to replace the infinity with the t because we're using that infinity in our limit. We won't use that until the very end. Of my function, which is 1 over x minus 1 dx. Now this one's a little different. Not much, but a little. Let's do the integration part first. What is how do you integrate 1 over x minus 1? You're going to have to do u substitution. You can't integrate a quotient. So what is u? And what is du? Okay, so we're going to have the limit as t goes to infinity. We're going to have the integral from 2 to t of 1 over u du. Now let's see if you learned a lesson Monday. What is the antiderivative of 1 over u? It is the natural log of u. Because if we did to this one the same thing that we did the one previous, you get u to the negative 1. And then if you add 1, that's going to be 0. Remember the smiley face and the sad face? Can't do it. All right, so we're going to have the limit as t goes to infinity of the integral from 2. Let's actually go ahead and apply the limit. Or go ahead and apply the integral. The antiderivative of 1 over u is the natural log of u. Are you going to be okay if I put u back in? X minus 1. And we're going to go from 2 to t. Again, the antiderivative of 1 over u is the natural log of u. But our u is x minus 1. Okay, let's plug in our boundaries. So we're going to have the limit as t goes to infinity of the natural log of t minus 1 minus the natural log of 2 minus 1. Let's clean it up a little bit. Can't do anything with the natural log of t minus 1, right? Because of the t. But let's think about this. 2 minus 1 is what? 1. And the natural log of 1 is what? 0. So this goes to 0. So we don't have to worry about it anymore. Okay? Now, let's actually apply our limit. So everywhere we see a t, we're going to plug in infinity. So we're going to have the natural log of infinity minus 1. What is that? What is infinity minus 1? Infinity. And how am I going to figure out what the natural log of infinity is? Cheat sheet. It's on your cheat sheet. The natural log of infinity is what? Infinity. Okay. Can a limit reach infinity? No. Therefore, are we converging or diverging? Diverging. So your answer is divergence.
Is infinity part of the answer too?
Well, I mean, I guess you could do, I guess to save me a little bit of time, you can put like that. Because if you tell me that it diverges, I'm going to look at your work and see why it diverges. Don't forget on your take-home test, you've got to show all your work. Because if you just write diverge and you don't tell me why it diverges, I'm not getting wrong. What's that mean? Huh? I'm going to mark it wrong.
What if we go down to marking zeros at infinity all the way through?
If you don't have any work, you can make a 0. That will be bad. Make a 0 on a take-home test that you have a whole week to do. And I've told y'all that y'all can take these problems and type them into Google and say, search. And most of these problems will either be on YouTube or something. Just make sure you show your work. Make sure you show the work. Okay. Let's do this one and we'll stop here. We'll let this one be the last one for tonight. Now Monday when you come in, I will, Lord willing, I'll finish chapter 10 and we will go ahead and start chapter 11. Okay? Once we get through chapter 11, y'all are pretty much done. Because chapter 12 is 112 all over again, and it's going to be so easy, you're just going to be like, really? So. Also, having said that, I've got all the chapters on Blackboard now, so you can print off all chapter 11, all chapter 12. By a week from today, of course, Lord willing again, a week from today, I should have your Filing and Study Guide on there with the solutions already worked out. So all you have to do is print that out, make sure you can get problems and so on and so forth.
Mine first test, like fix on there, because mine was like the first thing you gave us, and then you gave us like extra points because we redid that problem. Like that one wrong too, because we got right there.
It's not changed in Blackboard. It's changed in my grade book. I'll fix it. I think what I did is I just put those bonus points in that bonus point column. I think that's what I did. Okay. Do you see the boundaries? All right. So what we're going to have to do is we're going to have to split these boundaries up because we're going from negative infinity to positive infinity, so we're going to have to do that midpoint of 0. So we are going to have to split those up. So what we're going to do is we're going to go the boundaries of negative infinity to 0 of f of x plus the boundaries from 0 to infinity of f of x. Now remember on this one, you can do this in parts, and in fact I would suggest that you do this in parts. In other words, I would do the left hand side first and then the right hand side if needed. Why do I say that? The first one has to converge before you even think about going to the second one. Because if the first one diverges, you're done. Your whole thing, your whole answer diverges. Okay? So just do it in parts. I think that would be the easiest thing to do. So part 1, if you want to say that. Part 1, we're going to do the limit. And remember, we don't want infinities in there. Now this time we have a negative infinity, and we haven't done that yet. So you have the limit as t approaches negative infinity of your integral, taking the negative infinity out and replacing it with t, going up to 0 of your function. Okay, now from here, how are you going to integrate 1 over 1 plus x squared dx? What? see if Christopher needed bonus points. I give him bonus points, but he doesn't need them. So let's pull up our chapter 8 formulas. Do you remember what 1 over a squared plus u squared is? We used it a bunch last Monday. It is a tangent. So you're going to have 1 over a, tangent negative 1, tangent inverse, u over a, and we're not doing plus c because we have boundaries. Well, just out of curiosity, what is a? 1. What is u? X. Okay. So, this is chapter 8 stuff. So what we're going to do is we're going to do the limit as t approaches negative infinity. And I'm going to go ahead and write this. And that's from chapter 8. Now, we have the limit as t approaches negative infinity. And we're actually going to do the integral here. So when we do the integral, you're going to have 1 over a, which is just going to be 1, which is a coefficient. We don't really need it. I'll put it in there. And then you're going to have tangent inverse of u, which is x, over a, which is 1, so it's just going to be x. And we're going to go from t to 0. Do it. Because it's 1 over a. The a is 1, so you get 1 over 1. Off your chapter 8 formulas. So now we're ready to plug in our boundaries. So we're going to have the limit as t approaches negative infinity. 1 doesn't really matter, but we'll do tangent inverse of t minus tangent inverse of 0. What is tangent inverse of 0? Anybody know? Calculator is 0. Tangent inverse of 0 is going to be 0. So we only have to worry about the tangent inverse of t. Now let's apply the limit. The limit is going to be tangent inverse of negative infinity. Okay. So you don't have any formulas for that. But what I want you to do is get your book out. If you don't have a book, share with somebody. And we're going to go back to something that I talked about in chapter 8. And I said, remember this for chapter 10? Do y'all remember that? Do you remember me saying that vaguely? Remember this for chapter 10? Oh, it is on there. It's on your cheat sheet. That is a cheat. Big time. But let's look at it anyway and figure out why. Look at page 429. When we first introduced the inverses, on page 4, it is, number 8 on your cheat sheet. On 429, look at this. So you have your curve there, and remember we talked about how tangent inverse, when we take the inverse of it, our boundaries are going to go from pi over 2 to negative pi over 2. Well, as x approaches negative infinity, we're going to the left, okay, follow your blue line. As x approaches negative infinity, what is your curve approaching? Come on. Negative pi over 2. So that's why on number 8, if you have tangent inverse plus or minus infinity, it's going to be plus or minus pi over 2. It depends on which one you're going to. It all depends on which one you're going to. Well, don't let me do that backwards. Are you serious? Top minus bottom, Dana. Top minus bottom. Let's go back here. So we're going to have tangent inverse of 0 minus tangent inverse of t. Well, tangent inverse of 0, again, that goes to 0. So when I apply the limit of negative tangent of negative 1 of t, that's going to be negative tangent inverse of negative infinity. And you just told me that if tangent inverse approaches negative infinity, we're approaching negative pi over 2, which is going to be pi over 2. Now, if I had not have changed that, it would have been pi over 2, and I was thinking in my brain, this is not right. Approaching negative pi over 2, but I know it's the opposite of pi over 2, so that would be pi over 2. Anyway, so my brain was like, something's not right. And it was because I did the integral backwards. Can't believe y'all let me do that. Top minus bottom. Number 8 on the rules about infinity. Okay, so since we get an answer for the first part, then we're going to have to do the second part. So let's do part 2. But this won't take long at all. Since part 2. If we're going to get, because we're going to plus this, the integral, and this time we're going to go from 0, well, let's apply the limit. Well, I was ready to just wrap it up, but. Alright, so we have the limit as t goes to infinity of the integral of 0 to t of 1 over 1 plus x squared, which the nice thing is we've already done going all through the antiderivative and all this, that, and the other. So, we're going to have plus. Probably need to change the colors so you can see it. The limit as t goes to infinity here. Now, when we do the antiderivative, you're going to get the same thing. So you have the tangent inverse of x, but this time we're going to go from 0 to t. So we're going to have limit as tangent goes to, or as t goes to infinity. You're going to have tangent inverse of t minus tangent inverse of 0. Well, we know that this goes to 0, right? So now what we have is tangent inverse of infinity. And if we go back to that chart, or that picture on whatever page it was, 429, as your inverse tangent goes to, your tangent inverse goes to positive infinity, what are we reaching? You're going to reach pi over 2. Do what? Because she's already done it. Alright, so now if we add these together, pi over 2 plus pi over 2 converges, let's put it up here.
In the rule about infinity, number 8 there,
Uh-huh.